Due to some changes, today's first session is conducted by Dr. R.R. Gidde sir, and second section will be conducted by Dr. Bhargav sir. So, good morning, one and all. Gidde sir, are you ready? Can you listen me? Hello? Can you listen me, Gidde sir? Gidde sir, can you listen me?
Yes, sir.
Yeah, okay. Today's speaker for the first session is Dr. Ranjit Singh Gidde, that is R.R. Gidde sir. He is working as an associate professor in mechanical engineering department in Swaraj College of Engineering, Pandharpur. He has completed his PhD from Solapur University, Solapur, and he has published near about 22 essay papers on microfluidic. So he has a very vast experience as far as this COMSOL and microfluidic field is considered, and also his domain is microfluidic. So I request Gidde sir to please take charge and start the session and enlighten us regarding this COMSOL and microfluidic domain. So Gidde sir, will you please start?
Salunki sir, give me permission to share the screen.
Yeah, I'm going to give you permission. And Gidde sir, now you can share your screen, your host
Yes,
now.
yes, sir. Salunki sir, screen is visible?
Yes, sir. Your screen is visible now.
Okay. Okay. So good morning to all. So my voice is audible. I hope that it is audible to all the participants.
Yes, sir.
Okay. So today I will take one hands-on experiment or hands-on one modeling with respect to some micro channel. So I would like to share the screen. Accordingly, I have shared the screen. So directly I will open COMSOL multiphysics. Okay. Can you see the opening window for the COMSOL, Salunke sir?
Yes, sir, we can see it. You can continue.
Okay. So basically on the desktop, we can have such one COMSOL software. If it is installed, you can get the shortcut for the opening of the any software. So first of all, we have to select the blank model. So we can have model wizard, then blank model, then application wizard. So you can see the various windows here. So we can start with this blank model. So you can see the model wizard. Okay. So this is the display for COMSOL. So my voice is audible. Salunke sir, my voice is audible.
Yes, sir.
Okay. So this is the first display after opening the COMSOL. Then you can see the various things. First of all, you can see the file, then model and other respective tabs. So first of all, we have to select. So whatever object or whatever device I want to simulate, that is with respect to the micro mixer. So we have to select the study first. So just I have clicked on here, add study. So then for the model or whatever device, for that I have selected the stationary, that is the study. Am I audible? Am I audible? Then we have to select geometry. So through this add component, for that we have to go for modeling or whatever sketch we have decided. So here you can add 3-dimensional, 2-dimensional and other things, or whatever object we have decided or the device we have decided. Then after the geometry, we can add the required physics for the micro mixer. So micro mixer, it is a basically one component which is required to mix two fluids. So you can add the physics for that. So just by clicking here. So for the microfluidics, we required laminar flow. Just whatever model I have selected for that, this is the required. Then for the mixing, we have to select the transport diluted species. So this way we can select the two physics. Am I audible?
Yes, sir, you are audible. Please continue.
Okay. Then first of all, you can see this is the geometry. Then this one is the physics, laminar flow. This one is the transport diluted species. So two physics we have to use for modeling the micro mixer. So now let us draw first the geometry. So after clicking on the geometry, you can see the unit which we are going to use for the geometry, then this angular unit, then geometry representation, all these things we can see. But first of all, instead of going through all these details, you can just draw it on the work plane. So after right click, you can see here block, cone, cylinder, sphere, and other related geometrical parameters, or just the objects with which we can draw the model in the COMSOL. Now here we have to select the work plane instead of directly going for block. So just I will show you one block just by clicking on the right click on this geometry. We can draw the block directly. But instead of this, in the preliminary stages, you can select the work plane like this. So I have selected the work plane. So this one is the model builder. In this, we can have geometry and other physics and related things. And whatever settings with respect to the particular node, we can get in this settings. And this one is the graphics window. And whatever progress regarding the simulation, regarding the various stages, that will be appear in this message. So first of all, we have to draw the geometry. So I have selected this work plane. So just you can go here, again work plane. Then in that work plane, you can see the plane geometry. Okay. Now you can see this graphics in two-dimensional view. So just I will take a sample dimensions, and with respect to the two inlets, I will draw one rectangle. Then just by expanding this tab, you can get the rectangle. And here, this is the solid and the curve. Two options will be there in this object type, and the size is mentioned here, right? And it is in meter. So whatever rectangle we are going to consider, for that, the dimensions are given in the meter. Now, to change the dimensions, you can go here and you can apply here. So as we are going to simulate the micro mixer, we have to select the dimensions in the mm. Now you can see the dimensions in mm. So width for this rectangle is 0.2 mm. So just you can see, if it is 0.2 mm, then that means it is 200 micron. And height, I will mention here 2 mm. Accordingly, this you can consider as an inlet 1 and inlet 2, and we have to construct channel here, or we have to draw that channel on this, along this line. So again, we can fix the position for this rectangle. So this is the position. So again, if I will select a corner, then you can see this one is the 0 here, and this is the 0. And if you are going to consider the center, then it will appear like this. So it will start from this 0 towards this side. Okay. Now, generally, in case of the micro mixer, we have to consider length from this point towards this side. So if you are going to consider center for this is 0. So you can write, you can put here. Right? So that you can measure length, or just consider length from this 0, and accordingly it will be 4, 3.5, and etc. etc. Right? so that exact 0 will be followed from this point. Right? Understood how I have drawn the rectangle in two-dimensional? So, okay. Then to have a channel, again, I will select rectangle from this ribbon. Okay. Okay. Again, I will click on this rectangle too. Again, you can see this is width and this one is the height. So as we are drawing it in two-dimensional, these are the details with respect to the side. So I will write here 5 and I will consider width of the channel as a 2. Then again, for this rectangle, I will consider it as a center. Then you can see this way there will be two-dimensional figure. Now we have to start this rectangle from this 0. Then we can have position for this XW as a
Gidde sir, one request is there. Will you please slow down your procedure, what you are doing?
yes, sir. Okay. So should I repeat? Sanunke sir, should I repeat? Hello.
Yes, sir. Yes, sir.
Okay. So with respect to this work plane, this is the work plane. So here you can have three-dimensional view. So first of all, to model anything, we have to draw two-dimensional. We have to draw in the two-dimensional plane. So here, on clicking right click on this work plane, we can have different that build selected, build process, add before, add after. So like this. But once you are going to select this geometry, so I will repeat this stage. Sanunke sir, I will delete it once again. Okay. Now, this geometry is already added. Then this laminar flow already added. Then transport of diluted physics, it is already added. First of all, we have to model the geometry. For that, we are going to select this geometry 1. This is the main geometry on that work plane. So this is the work plane view. Then under this work plane, you can see the plane geometry. So two-dimensional display in the graphics, you can see hello. So I have selected this plane geometry. So just by clicking this work plane, you can see the three-dimensional view. Once you are going to select work plane, after clicking this geometry, you can get this work plane. then the plane geometry. Now to draw the geometry of the micromixer, we are having different options. Here you can draw the line. Just by joining the line, you can get the rectangle, or directly you can select the rectangle. So just you can select square or the rectangle. And again, if you want, you can change the dimensions to make it as a required component of the geometry. Now for inlet, we have to select the rectangle. So just I will give the dimensions. First of all, fix the position. Okay. So this I will represent as the inlet 1, this as the inlet 2, and again I have to draw the channel here. So for that, I will select one rectangle. Here I will mention width as a 6, height as a 2, and again I have to get the exact position at this 0, so that again I will consider it as a corner, or if I will select center, then you can get such drawing. So instead of that, if you want to start from this point, you can select its a position to the corner. Then here you can directly put the 0, and this is for y-axis. So position y-axis, so 0.2 mm, that means 100 micron. So it should be below 100 micron from this 0. So this is the two-dimensional geometry. Okay. Now I will consider this as the inlet 1, this as the inlet 2, and this one is the outlet. So now we have to make union of these two components so that you can get the micromixer. Now you can see by clicking this plane geometry, you can see here various nodes. Then here by this Boolean and partitions, you can have 4 options: union, intersection, difference, and the compose. So to make union of these two rectangles, we have to select this union. After clicking to union, this is the setting window. We have to select this rectangle and this rectangle. Okay. Okay. So this one is the setting. Here you can see union, built selected, built all, union 1, then input objects. So you have to ensure that it is active so that you can select these two rectangles. Now just by clicking this, it is automatically selected. Again, by clicking this, it will be selected. If you want to erase the selection, you can go to this brush and clear the selection. Okay. So I will select this R1, that is rectangle 1, then R2, that is rectangle 2, just by clicking these two rectangles in the two-dimensional. Am I audible? Am I audible? My voice is audible?
Yes, audible.
Okay. Then after clicking to build selected, you can see here this, though these two components are united, or we have provided that union command till you can see the boundary. So because it is selected here, this block is selected. So if you can click here to unselect it, and then again, if you are going to click here build selected, then you can see the union. Now our two-dimensional figure or whatever design of the micro mixer for sample dimensions we have drawn in the two-dimensional view. Now again, to make it three-dimensional, you can go for the extrude. So just by clicking on this work plane, previously I have shown various options. Now we are drawing in this work plane number 1. Under this plane geometry we have drawn. Then to extrude it in perpendicular direction or to the plane of this perpendicular to the plane of this screen, then we can go for this extrude option. You can see here, this one is the two-dimensional in the top view. Now to give it some thickness or the height to that particular channel, automatically you can have this 1 mm, that is default value. Now the cross section of the micro mixer, if you are going to consider it as a 0.2 by 0.2 mm, then we have to consider this. This is the 0.2, this one is the 0.2, cross section of the channel is 0.2 by 0.2. Okay, understood? So again, this one is the two-dimensional view. Again, to give height to the channel, we have to extrude it. Here, extrude from work plane number 1. Again, you can select work planes. Again, you can draw another component, so that may be required in the different application. Again, if you can go for the extrude, then here you can see the work plane number 2. So that's why while extrusion or while providing that height, we have to carefully see the work plane and from which work plane. So just I will delete it just by right clicking. Or sometimes you can have this disable option as well. Now I will just disable this extrude. Again, you can see the two-dimensional view in the work plane. And if I will enable, again you can see the three-dimensional view. Am I audible?
Yes, audible.
Okay. Okay. Now this way you can get the final geometry. Now if you are going to draw it in some parametric manner, so we have to add this parameter. Here you have to mention W for the width, H for the height, and accordingly you can get put the various values, and that can be applied here for changing the width and height as per our requirement. So that is called as a parametric design. So every now and then, just by putting the required values in this parameter, you can get the required drawing immediately. So that is the benefit of the parametric drawing. Okay. So after completion of this model, now whatever physics we have selected, we can go for that. Then we are assuming, or in case of the microfluidics or microflow, there is laminar flow due to the dimensions. So this is the laminar flow. This is the graphics window. You can see settings for laminar flow. This is label, then single phase flow, and you should remember that here we have to select manually, or sometimes it is directly all domain based on our requirement. Now, whatever three-dimensional view in the graphics, that we are going to consider as a one domain. So that's why you can see here this object or two rectangles in the two dimensionals, we have provided union to that, and now we can consider this as a water domain. Okay, then with this node you can have properties. So fluid properties. So with respect to this domain, we have to give here from material. Now this is the design of the channel. So physics we have selected. Now you can see from material. So for that we have to select the material. So already I have selected that laminar flow and transport diluted physics. So material. So we have to mix two fluids. So just by clicking this material, you can add the material. So add material. Here you can see different materials. So just by clicking on the right hand side of the screen, you can see, you can search the material. Okay, so material library. Here you can see elements, iron alloy, different things. Then some of the materials. Okay. Now basically in the micro mixer, so as an case study, we can consider water and the ethanol. So under this liquid, you can see here water. Just by right clicking, add to the component, you can get the water material under this materials. Then second fluid, which I want to mix with the water, that is the ethanol. Okay. Once again, for your information, I will show. Okay. Right click on this add material, or sometimes you can search directly. Here also you can get the water. Okay. Then what is second material? That is ethanol. So those who are practicing on this, they can add the material water and ethanol. My voice is audible?
Yes, yes, audible.
Yes, sir.
Okay. So water and ethanol is added now as a material. So we have to consider this domain as a water. So there is not necessary to provide ethanol to this domain. So generally we are going to consider this as a water domain. So accordingly, one it is selected. So these are the properties of the water. So you can see this dynamic viscosity, density, ratio of precipitate, electrical conductivity, heat capacity, thermal conductivity, and speed of the sound. Again, if you want to add the properties manually, then also you can add just by clicking here under this material properties. Okay. Then properties for the ethanol, or sometimes you can add blank material and give the respective properties. That is also one of the option. Okay. So after completing the geometry, this one is the three-dimensional geometry. Then we have added two material. One is water and another one is ethanol. Then we have to go for the physics. After selecting the material, already I have selected, that's why I have told something regarding this laminar flow. Then for this laminar flow, this domain is we have selected, and that is you can see from this settings. Okay. Then so whatever governing equation based on the stationary study, a study type already at the start only we have selected, and other things. Okay. Now here compressible flow and incompressible flow. So we have to select incompressible flow. So for turbulent model type,
Good day, sir.
hello.
Yes, sir. There is one question in chat box
1 minute.
from Gulam Ansar, sir.
1 minute. Hello.
Yes, sir.
Gulam, Anwarji, hello. Am I audible?
Yes, sir, you are audible. You please give
Yes,
answer.
sir, you are audible.
Okay. So basically, when we are selecting a material from this direct material from the COMSOL, so these properties. So for example, for this, here you can see the temperature. So whatever question you have asked, the value of density and the other properties showing as a function of temperature. So this water and ethanol. So in some of the literature, we have to measure these values at particular temperature. So for 20 degree, for 25 degree, there is going to be variation. So there is changes in these values. So all these are the temperature dependent property, density as well as the dynamic viscosity. Okay, so for the particular study, you have to mention, or before going for the experimentation, you have to measure the dynamic viscosity and the density at certain temperature. So if you have seen the various literature or the papers with respect to the micromixer, there are properties, and along with that property, at which temperature they are measured, that is mentioned. Should I answer your question? Anwar?
Yes, sir. Thank you, sir.
Okay. Or just if you want, I will show one paper. So whatever paper available with me that I am showing. Okay. The fluid properties were taken for water at a temperature of 20 degrees Celsius. So that we have to mention. And this is the important assumption if you are going for the simulation related work. You have to take a reference from any of the previous literature, and accordingly you can put the value of the temperature. Okay. Okay. Salunki sir, should I proceed?
Yes, sir. Yes, sir. You can proceed.
Okay. Now under this laminar flow or this physics, you can see the settings for laminar flow. So various settings are there. So we are not going for this turbulent model. Only we are going for this laminar. So under this, you can select the various this KE and KW, SST, different turbulent models are there. So we are not going for that. Okay. So this is the governing equations with related to the laminar flow. So already here it is equation for steady controlled, or if we are going to consider the stationary, automatically you can see that display. Here steady control means whatever study we are going to select under this study option, accordingly there will be governing equation automatically gets selected. Okay. Then the fluid properties, from material. So whatever material we have selected, or if you want to put, then you can insert the desired or the measured value of the density for that material. Again, you can go for this. Okay. So it can be user defined, or in the preliminary stages, it should be from the material. Okay. Then we have to give boundary conditions with respect to the wall. So there are different conditions: slip, no slip, sliding wall, moving wall, leaking wall, electroosmotic velocity, and the slip velocity. So generally for the micro mixer, we are going to consider no slip boundary condition. So this is setting for this wall boundary condition. Again, as per the study here, U is equal to 0. This is the governing equation or equation we have chosen. Then initial values. So velocity field 0, 0, 0, and the pressure 0. Not necessary to put any value from our side. Okay. Then as a micro mixer, we have to select just by clicking two inlets. Again, I will right click. Again, I will select inlet 2, and there will be one outlet. Okay. Now, under this laminar flow, fluid properties we have seen from the material, boundary condition for wall. So just by clicking on these numbers, you can get the different surfaces of this channel. Okay. Then the initial value. Then, as I said previously, this is inlet 1, this is inlet 2, and this one is the outlet. So inlet 1, this you should ensure it as an active. Then settings for inlet 1. Here, if you are going to consider all boundaries, but we have to select this boundary only, so you can select the manual option. Okay. Or if you are going to consider all the boundaries, then just by scrolling down, you can see how boundary gets selected, or directly after clearing the session selection, you can get the inlet boundary. Just you can this is inlet 1. We have selected this boundary as the inlet 1. Now to select inlet 2, we have to just turn this. Okay. Now inlet 1, for that this one is the boundary 2, and inlet 2, this is inlet 2. Okay. Now to select boundary for this outlet, you can go for this, go to XY view. This is XY view. This is YZ view, and this one is the Zx. So if you are going to see, this is X, this one is Z, and this is Y. So X direction, along this X direction, there is length of the channel. Now we have to see this outlet. For that, you have to get this YZ plane. So you can click here. You can see this outlet, and just by clicking, you can select this boundary. Or just by clicking, you can select, or also you can clear the selection by clicking on that boundary. Okay. Okay. Now we have selected inlet 1, inlet 2, and the outlet. Now we have to give specific conditions. So inlet 1, it is specified by this boundary 2. Then show equation assuming stationary as per our study. Then the boundary condition. Under that, you can give boundary condition in terms of pressure. This equation automatically gets changes. You can give the laminar inflow, and you can provide this mass flow as well as. So generally, if you are going to consider the mass flow, we have to give mass flow rate, then pressure, some value should be there, and we have to consider the normal flow. Now, for this case study, I will select velocity, then normal inflow velocity. I will assume here 0.001 meter per second. So I have to consider 1 mm per second. So accordingly, I have selected this 0.001 meter per second. So that value we can change afterwards. So for this inlet 1, we have selected this 0.001 meter per second as a velocity. Then again for inlet 2, there should be same value. That is the inlet related to the ethanol. Okay. Then for this outlet, again for the outlet, pressure, laminar outflow, and the velocity. So we can go for the pressure, and here you can don't put any value, keep this as a 0 as it is. Okay. So this is about this laminar flow and the physics, whatever nodes under this laminar flow. It is very, very simple. So we have considered inlet 1, inlet 2, and the outlet. Inlet 1 we have specified with boundary 2, inlet 2 specified by this boundary 5, and outlet by this boundary 10. Now we have to go for this transport diluted species, the another physics which is required for simulating the mixing or visualizing the mixing between the two fluids. Okay. So with respect to this, so this is transport diluted species. Then this one is the graphics window, and this is the setting for transport diluted species. Okay. Now, governing equation for this, it is based on this convection, this adsorption, then dispersion, polarization. So convection diffusion equation. So generally we are assuming the mechanism includes the convection. So this one is the governing equation, or whatever assumptions we have made. Equation for, again, it is steady controlled, stationary one. So again, with respect to this transport diluted species, okay, here, so here we have selected velocity, here we have selected as a boundary velocity, here pressure. Under this physics, here it is convection, already selected. Here you have to select velocity field, or you have to mention or user define. Two options are there as an model input. So simply select velocity field. Then, as we have to mix this ethanol with the water, so generally for any fluid, to measure its a diffusivity with respect to the water, so some of the values already available, and those are with respect to the water. Now this diffusivity of the ethanol, so whatever material we have selected here, so diffusivity of water, diffusivity of ethanol in water, its value is this, you can see, meter square per second, or based on the value given in the literature, if we are going to provide some reference and simulating that flow of any two fluids, then water and the another fluid, that fluid will have value of diffusion coefficient with respect to water, and that is mentioned. So now here we are mixing ethanol with the water. Then this is user defined value, or you can change here. Simply you have to keep this isotropic as it is. Then under this node, not necessary to do anything. Whatever display you are going to see in the setting, there should not be any change. Keep as it is. Then initial value, again here 0. Here initial values with respect to the velocity, that is 0. Similarly, now in case of the transport diluted species, we are going to consider the concentrations. So that's why initial value is also for the concentration, it is 0. Now we have to consider the concentration of that ethanol and the water. Now just I will open the paper so that you can get idea regarding the properties. So already these properties we have seen. Okay. So generally we are going to consider concentration of that second fluid. That is the fluid which is to be mixed with the water. So, and when they are going to consider as a fully mixed, whenever they are going to demonstrate the equal concentration. So now for this concentration, initial value it is considered as a 0. Then we have to add concentration 1 and concentration 2. So this concentration 1, it is related to the water. Just I will select here. So inlet 1, here concentration 1, it is with respect to this inlet 1. Again, I will select this 2, and here you can write, here you can put value as a 0 mole per meter cube. Then for inlet 2, we have to select this inlet 2. Here again select basis C and 1 here. Okay. Am I audible?
Yes, sir, you are audible. You please continue.
Okay. So concentration 1 and concentration 2. So this is related to the ethanol. This is related to the water. So ethanol concentration is that we have considered as a 1. So any value, or if I will write here 10, then also no issue. If I will write there 100, so this value is representative for that particular fluid which has to be mixed with the water. So 100, 200 or 1, that we have to consider, and that has to be mixed with the water. So don't bother about the value. Now concentration 1, that is related to water, that we have considered as a 0 mole per meter cube. Then concentration 2, that is related to ethanol, that we have considered as a 10. Now we have to show the outflow. Water, ethanol, and the outflow. So again, just by right clicking this transport of diluted phases. Okay. And now we have to select the particular boundary. Again, you can go for this YZ plane. Okay. Now you can see the complete model of the microchannel. This is inlet 1, inlet 2, and this one is the outlet or the outflow with respect to this physics. Just again the original view. Okay. Okay. Salunke sir, am I audible?
Yes, sir, you are audible, sir.
Okay. Now what we have done till time, just I will revise this work plane. Under this work plane, we have drawn 2-dimensional geometry. Again, just by providing the extrude command, you can get the model of micro mixer. Then we have to consider the materials, water, and the ethanol. So we are not specifying any domain for the ethanol. So directly you can allot this boundary for boundary number 5 for the ethanol in this second physics. Then we have selected the laminar flow, then fluid property, boundary condition for wall. Now here boundary condition for wall, and you can see for wall number 2 and wall number 5 there is overridden. That means we have provided inlet to this 2 number boundary and inlet for this 5 number boundary. So that's why it is overridden. Okay. Then this transport of diluted species, second physics, we have seen the properties. Then this as it is, here also you can see 2 and 5. Then initial values, initial value again here 0 with respect to the concentration, concentration 1 and concentration 2. Concentration 1 again it is for water, that we have considered as 0. Concentration 2, that is with respect to the ethanol, and this is the outflow. And whatever equation we are observing here, that is automatically based on the selection of the study. Okay. Then last part with respect to this, that is selection of proper meshing or just meshing of the model. Now, in COMSOL multiphysics, after clicking to this mesh, you can see here in this middle window, settings. Under this mesh setting, you can see physics control and user control, and these are the element sizes. Okay. With physics controlled and with this normal element size as it is, so whatever physics we have selected, that means this laminar flow and the transport diluted species, based on this you can have sequence type physics controlled or user controlled mesh. If you are going to click for this user controlled mesh, then you can see different nodes under this mesh 1. Okay, just I will show you again here. After clicking to size, calibrate for fluid dynamics, calibrate for general physics, calibrate for plasma, calibrate for semiconductor. Now it is related to the fluid dynamics, so you can consider here fluid dynamics. Then element size parameters. Then here element size, maximum element size, minimum element size, maximum element growth, curvature factor, resolution of narrow region. So preliminary, you should not worry about these things. You should use physics controlled mesh, and once you can get enough depth into this, then you can have variation with respect to this element size, or you can work for the meshing. Now here predefined. So for course, these are the sizes. Again, if I will click here extremely fine, automatically it will get changes. You can see. Okay. Then again, this size 1. Here, if you want to give it particularly to the selected boundary, particularly to the domain or the edge. Those are the different things. Then corner refinement. So this you can get expertise by trial and error method. Then again, with the user selected, 3 tetrahedral one and boundary layer. So my suggestion to all the participants, so initially you should have this physics control the mesh. Once you get your problem statement clearly, what you want to mix, what type of study you want to do, then you can go in details with respect to this particulars regarding the mesh. So just physics control the mesh. Under that, we have selected this normal. Again, you can select extremely fine, finer, fine. But initially, for every solution or every simulation, for the pilot simulation, you should go for this normal, and then you can check the accuracy just by moving in this direction, or for fine, finer, extra fine, or the extremely fine. So the laptops or the computers who are having less compatibility or that less RAM, then in that case you can go for this extremely coarse. So here I will select normal, and just by clicking this build all, okay, here you can see the message in the graph below the graphics window. Finalized geometry is empty. Finalized geometry has 1 boundary, 4 edges, 4 vertices. Finalized geometry has 1 domain, 10 boundaries, 24 edges, 16 vertices. Complete mesh consists of, because whatever mesh I have done. So again, I will just clear the message. So, and I will go for this course. You can see complete mesh consists of 40,000, around 40,000 domain element, around 7,000 boundary element, and around 800 edge element. That is displayed here. Okay. So just we are going to select the normal. Again, with the normal, elements are going to be increased in each case. Again, if I will select finer, so it will take some more time as we have decreased the size of element. So it will take more times. So we can see the progress by clicking the progress. Here final message and here progress. So initially don't bother about such things, message, progress. Okay, okay. Now you can see with finer element size, the complete mesh consists of 66,000, sorry, 6,67,000 domain elements. So between this normal to finer, around 5 lakh element, difference of 5 lakh element is there. So to get more accurate simulation or the characteristics or the performance, you have to go for the finer and finer mesh. Okay. So to get solution in less time, I will select this normal. Just this is an example how element size is going to be changed and what accurate you can get by increasing the element size. Sorry, by decreasing the element size. Okay. So just again, I will shift to this normal meshing. Okay. You can see this is the meshing. Now, if you want to get more details about the meshing, just right click on this mesh. Here, statistics. Just by clicking the statistics, you can have a complete statics of mesh, a complete mesh. How many tetrahedral elements, pyramid elements, prism elements. Initially, don't consider all this or don't look into all these things. Only you have to use the user or physics controlled mesh. This is for your information. So number of elements. So you can see here 81,011 that you can see. Then this is somewhat regarding the element quality, minimum element quality, average element quality. So average element quality, you should target it for 1, but it is not possible. That will considered as a best, or you can get the more accurate result. Okay. And these are the other things, mesh volume. So that is equal to the volume of this channel, maximum growth rate, average growth rate. And you can see this histogram with respect to the element quality. Okay. Okay. So this way we have finalized the geometry as well as mesh is provided. Then this clear the message so that whatever new step we have carried out, that should be visible at this start. Now, the last part, that is the study. So study already we have selected as a stationary. Here directly compute is there. Just you can see we have selected two physics, laminar flow and transported diluted phases. Just for flow, you have to deselect this. But as we are simulating mixing of two fluids, we have to select this second physics as well. This is the physics setting. Okay. Now the last part we have to compute. Okay. So what we have done till time, we have created geometry just by selecting work plane, then extrude, then we have selected a material, then laminar flow, then transport of diluted phases, then we have created the mesh using physics controlled mesh, and last part is study. Now under this study, you can see the compete, that means competition of this model with respect to the mixing will be carried out automatically. Okay, just by clicking compete, you can see the progress. Now 14%. Initially, you have to wait and watch, and you should have more practice on such simple. Okay. Okay. Now here, solution time, 86 seconds, 1 minute, 26 seconds. Now other details you can see here in this log, everything. But initially you should not look into these things. Okay. Now we got the solution for this mixing of two fluids. Now just we have to work on this simulation. So after study, you can see here results. Here you can get the values just by adding some of the required parameters here and calculate the performance of this micro mixer by putting details with respect to the output parameters. Okay. Then just I will show you some of the plots related to the concentration. Okay. Now here water was assigned, here ethanol was assigned. Okay. Now here, just by clicking the slice, or you can select slice or the surface as per our requirement. Just I will show you related to the concentration, as mixing is going to consider based on the concentration at the outlet. So here slice, under this setting of slice, YZ plane. Now what we are observing, XY. So we have to select here XY. Number of planes, or you can specify the coordinate. Now as height of the channel is 0.2 mm, we can give the coordinate perpendicular to the screen of value 0.1 mm, and again we can have the plotting. Okay. Now this one is the water, this is the ethanol, and what you are going to observe, there is mixing and it is increasing progressively. It is increasing progressively. Okay. Now This way, the plane at the middle height of the channel, okay, inlet 1, inlet 2, ethanol, water, and this is the mixing channel. Now we have to see the plane, this YZ plane or the outlet plane, to get idea. So we have to click here, go to YZ view, go to XY view. This is the view, XY view. YZ view means we can get the YZ plane or the outlet plane. Now again we have to change the setting for this slice. Here we have to select YZ plane, and if you want to see this plane, then we have to write coordinate in that direction. So I will write here 6. Okay. So why I have written 6? Because from this 0, this plane is at 6 mm. So directly I have written here coordinate as 6. Or instead of this one particular plane, if I want to see more planes, number of planes, then I will write here 5, if 10, if 7, if 15. Accordingly, you can see planes along this length of channel at particular or desired location. Or if I will write here 20, you can get the 20 planes. Or through these 20 planes, what you can see, just I will, okay. Here, water and ethanol, water and ethanol, water and ethanol. As flow proceeds, mixing is increased. We cannot differentiate between water and ethanol. And that is the stage where it is called as a mixing of 100% or two fluids mix with 100%. Okay. Now you can see here, whatever concentration profile towards end, what you are observing, purely green. So blue, this red, it becomes green. Okay. Okay. Now here you can see this legend, color legend on the right hand side, 0 to 10. 10 is concentration of ethanol and 0 is concentration of water. Now looking to this legend, so whatever color at this 5, right? So that should be at the outlet to have the 100% mixing. Okay. Again, to go for the original view, whatever way we have simulated, then you can go for this model. Then here reset window, automatically you can get the, okay. Now again, to see the velocity counter, similar process. Again, if I will write here plane 1, then the same way you can get the view for this. This is the velocity contour for the whole channel. Okay. Again, if you want to see on YZ planes and 5 planes, you can have this way, or just I will write here 20, similar to the concentration. Okay. you can create such view just by putting the number of slice. Okay. Or this is about velocity, this is about again concentration, and this is regarding the pressure. This is regarding the pressure. Okay. So as we have given very less velocity, so the pressure drop you can observe, the maximum pressure is up 9.73 and minimum that is 0. So Salungi sir. Salungi sir. My voice is audible?
Yes, yes. Now,
Okay. So this is from my side. Any questions?
I request to participants, please ask questions if you do any doubt.
it's audible, sir.
Yes, yes.
Yes, yes. Actually, I'm the field of biosensor work. So how can you convert this microfluidic design to biosensor work? Because this is simply the flow, how ethanol and water flow together in the microfluidic channel. But I want to send two chemicals to sensing the analyte present in the chemicals by using the MEMS sensor, my MEMS or NEMS sensor. So how can you convert this microfluid to biosensor, or my microfluid sensor to MEMS biosensor?
So can you repeat your question, sir, please?
Is it audible?
Yes, yes.
Yes, sir. Actually, sir, these are microfluidic things, but actually I'm working in the biosensor world. So I'm sending 2 to 3 chemicals. If I take example of blood. So if I sensing the blood property by using antigen and antibody, so what is it important to convert, or is it possible to convert this microfluidic sensor to MEMS biosensor?
So actually we have to introduce one more physics regarding the sensor. So now what is a sensor, or what type of sensor you are going to use for that particular sensing action? So that feasibility. Hello?
To finding the antigen present in the blood. That only I'm going to sensing by using this microfluidic or microfluidic integrated MEMS biosensor.
Microelectro. So can you share your problem so that I will work on that, and I will communicate with you, because that is new area for me. So actually,
yes, I will contact you directly.
Yes.
Can you explain this thing about what you?
Hello. Your voice is not audible.
Will you please ask question?
It's audible there?
Yes, you are audible now. You
So this microfluidics device what you drawn, sir. So how can you explain about the application of these things?
साळुंके सर
yes, sir. Yes, sir.
काय त्यांचा प्रश्न व्हॉट इज देअर क्वेश्चन
Actually, I didn't get that question. He has written, sir. He has written. In chat box, you can check it.
हा हा
You are not audible, Gidde sir.
हॅलो एम आय ऑडिबल
Yes, yes. Now you are audible.
Okay,
You
okay.
just check.
So what
chat box.
purpose we can use? So that is one question. So actually these micro mixers, these are the devices or simply the components used in the microfluidic application to have mixing of two fluids or some of the other applications in the biomedical field. These are the devices used. Salunke sir.
Yes, sir. Please.
Okay, I have written an answer in chat box as well.
Okay, you have written the answer chat box. Okay, anybody else want to ask question? Please ask.
So next question, is it possible to study mixing of three fluids and get at two outlets? So it is possible to mix three fluids by providing three inlets, and we have to get that output in two outlets. Accordingly, we have to draw the geometry, but we have to check the feasibility of the fabrication or getting the output. Dhananjay, hello. Okay. Yes. So you can have that model with 3 inlets. We can allot 3 fluids, that fluid 1, fluid 2, and fluid 3. And we can get the 2 outlets as well. So that one end point or one fixed length we have to decide, and after that we can get the 2 outlet. But thereafter there is no change in the mixing. As we have provided 3 inlets, to get the 2 outlet doesn't have any meaning. The same mixing will be observed at 2 outlets. If outlets at one particular locations.
Any other question, please? So there is question in chat.
Yes, yes. So next question, this is all is due to convection and diffusion. Of course, it is due to that only. So we can have study in the microfluidics. Is it the case?
One more
Hello.
question is there in.
Hello. Both the studies we can do in
Yes,
microfluidics. So we can do both the studies in microfluidics.
Thank you. Is there any other question? Okay, sir. Gidde sir, I think nobody is asking question now. So on behalf of all participants, I would like to thanks to Dr. R. Gidde sir for giving session on microfluidics. And in future also, if you do any query or question, we'll definitely contact you. And I request all participants to ask that query or question to Gidde sir. He is always ready to give answers of such questions. So from the organizing committee as well as from mechanical engineering department and HOD Dr. Wankar sir, we all thanks to Dr. Gidde sir. And here with the permission of Gidde sir, I declare that this session is over. We will again resume at 3 o'clock. Okay, thank you, sir. Thank you, Gidde sir.